Alright, so just looking at this question all the way to D, I can see that when I graph this equation, I'm going to get some 3 on 2 somewhere, some y equals 3 on 2. Anyway, let's have a look. So first of all, we want to show that, so we want y dash. So quotient rule, differentiate the first times the second, or times the bottom, minus differentiate the bottom times the top, all on the bottom squared. Alright, so looking at that, you can see this is negative 6x, so I'm getting 3x squared. I'm going to get negative, oops, sorry, that's a negative 6x squared, and I'm going to get a positive 3 as well. So negative 3x squared plus 3. So if I put a 3 out the front, I'm going to get a 1 minus x squared. So I'm going to get a 3, difference of 2 squared, 1 minus x, 1 plus x, all on the bottom squared. Alright, so that's all good. Hence find stationary points. Alright, we know for stat points that means f dash of x equals 0. So let's be naughty in our working and just make that equal 0. You can see just from the top, because the bottom's positive. So the top I want 0, so x will be either 1 or minus 1. And then of course I'm going to have to put it in here to find my y values. Alright, so if I put 1 in, I'm going to get 3 on 1 plus 1, so 2, 3 on 2, oh there we go, 3 on 2. If I put negative 1 in, I'm going to get negative 3 on 2, there we go. Alright, okay, so we've got those two values. Now what do we have to do? And we already know that. So let's get a bit of room. We want to determine their nature. Alright, so doing a double dash is probably a little tricky, so let's just go straight for our table of values. For our x values, we want minus 1 and 1, because we know are stationary points. And let's try 0, 2, and minus 2 then. Alright, so if we have a look at y dash for, let's do 0 first, that's easy, so let's put zeros in here. So we're going to get 3 times a 1, and it's all on a positive, so we know that's going to be a positive there. Alright, let's put the positive 2 in. So we're going to get a positive 1 minus 2, so times a negative, so negative, and then what did I start putting in? 2 plus 1 is positive. So I don't know why I put negative 1, but anyway, I'm going to get a negative on top, and of course it's positive on the bottom, so that's going to be a negative. Putting negative 2 in, so positive times negative 2 would be a positive in the next bracket, and then negative 2 would be a negative in that bracket, so I'm going to get a negative there. So just putting it kind of, that's positive, and then what will it be in there? That's going to be positive, and then in here it's going to be negative. So that top is going to be negative over a positive bottom, which is negative. So you can see it's going to go decrease, 0, positive, increase, 0, decrease. So the curve's going to have that general look to it. All right. So we know that so this one is going to be a maximum stationary point, max stat point, and this one here is going to be a minimum stat point. Okay, so we know that already. So if we sketch it indicating any important, very important, whoops, totally missed the line, excellent work. Alright, so at 1 and minus 1, so at 1 it's a maximum, and at negative 1 it's a minimum. So it goes something like, we can also actually have a look at this curve. You can see when I sub in 0, we're going to get 0. And I can tell when I sub in negative x, it's going to be an odd function as well. And the other thing I know is as x gets really, really big, you can see this is going to win on the bottom. So it's going to go towards 0. So it's going to have an asymptote. So if you can't remember, the limit as x goes to infinity, if if I divide everything by x squared, every single term by the highest powered x on the bottom, so 3x on 3x squared is 3 on x. X squared on x squared is 1, and then I've got 1 on x squared. So you can see both these terms are going to go to 0. So we're going to get 0. So as it gets bigger, it's going to go towards 0. So what does that look like? Well, it must look like, because that's a minimum, and it goes through there. That's a maximum. There we go. You can try out a few numbers as well, but it's going to look something like that, where that, remember, is minus 3 on 2, and this is 3 on 2. Something like that. All right, so now if we're going to solve this question here, hence, how many roots are there for this equation? So so we've already graphed y equals that. So now let's graph y equals c. So if y equals c, or let's do c equals 0 first. So if I graphed that graph, then I would be graphing y equals 0 across there, and you can see it only cuts once. So there'll be one root for that one. All right, let's go for this one. C equals 3 on 2. So C equals 3 on 2 also once. Right, C equals 3. It's there, 3 on 2 touches once, so there's going to be one real root. All right, so then C is greater than 3 on 2, so it's going to be up here somewhere. We're going to have no real roots. No real roots. And then C is between 0 and 3 on 2. What is 0, 3 on 2? All right, so anywhere between 0 and 3 on 2. You can see how many times it's going to cut. It's going to cut 2 times. So when we've got the between one, we've got 2 real roots. So don't forget, you can just draw 2 graphs.